Move on to the final presentation in this session, and very much welcome Coda-partner WellSafe Solutions, Neil Copland, Senior Well Engineer with WellSafe. Neil's going to talk to us about lightening the P&A load, wellhead loading for old, weak wells. Welcome, Neil, and WellSafe.
Yeah, thanks very much, Sean. My name's Neil Copland, and I'm just going to run through looking at lightening the P&A load. And to begin with, I'll just give a bit of a background of WellSafe and why wellheads and the issues that come up with them are of interest to our company. So essentially, WellSafe are a company that work within the decommissioning sector but are purely based on plug and abandonment of wells. Started in the UK a few years ago, and that encompasses pretty much everything from the front end engineering, looking at categorising the wells, looking at operational steps, programming of that through to actual offshore execution, interfacing with those wells, and that can be with other assets or our own assets and our own BOPs. So part of what we've seen over the years is the issues with some of the legacy equipment that we've got around the world, and the fatigue and the strength problems that they have. WellSafe started an offshoot of the UK in Australia at the end of last year. So it's something that, it's relevant to Australia as well as globally. I'll just run through a bit of an introduction of the issue in a bit more depth, looking at old versus new in terms of the wellheads and some of the systems that we've seen, what that means for the loading and the fatigue of those, what mitigations we currently have in terms of new technology, existing technology, what that then does to your operability and your windows. One of the other mitigations that we're starting to look at and starting to see in the industry is lighter BOP stacks and what can be done with that, and then just try and wrap up with a few conclusions. So introduction. As rigs have progressed through the years, different generations, one thing that's also progressed with that is the weight and the height of BOP stacks. And because of that, there's been obviously reasons for that, but one of the things that has also gone up with that is that the bending moment and the load that puts on the assets subsea. So we've got now a lot of stock globally that was drilled with BOPs that were in kind of 70-ton region, that we're now putting BOPs that are up to kind of 500 ton. And there's obviously issues that come with that, and when you start to look at the analysis of that, it gives you windows for your operations that are essentially can come down to being unusable, which obviously causes an issue when in decommissioning you're looking at, you have to go on there and you have to plug and abandon these assets. So in terms of old versus new, the table's up there. I'm not going to go through that, but I guess the key highlight of it is that if you look at some of the strength capacity from the systems that you had in the 70s through to what started to get deployed in the 90s, there's a really significant change in that, and the capacities that they have. But some of the biggest problems that we've seen with the old assets is data. So sometimes there's no well records, sometimes there's limited well records. And really, to have accurate analysis, you need a lot of quite well-known and defined parameters, which we just often don't have. And because of that, it leads to some pretty conservative assumptions having to be made, all of which then kind of drives you down a route of having pretty low operability windows. Some of the kind of key issues, it's the materials that were used, the weld quality, the fact that they were drilled, as I said, with small twin stack BOPs. And then also, a lot of the old wells had quite a significant time for drilling and completing, which then increases that fatigue and reduces the available fatigue you have for doing your P&A. Again, this is just kind of for information, but this is a kind of typical analysis that we've done for the southern North Sea. But the typical range we see for the legacy wellhead capacity is 2,000 to 2,700, and you'll see there, kind of straight off the bat, one of the modern day BOPs down at the bottom, you're already above that. So before you've even started, you're just kind of your first pass of analysis, you're looking at exceeding what the asset's actually capable of withstanding. And then in terms of that strength, what that means for fatigue, Again here, if you look at the bottom, that's your kind of standard generation BOP now. It's giving you an actual fatigue life of very low, 0.36. So all these things, as you increase through the weights and the BOPs, they really start to impact the kind of window that you've got to go on there and do the P&A. And the fatigue is something that you kind of have to try and manage to allow you to get that window and get this completed. So what are, I guess, the mitigations that we've seen and that we've used? So there's a few that are kind of well defined and well known. Tethering, BOP tethering. So if you look at the top right there, there's kind of two styles of tethers. So you've got the mud mat tethers and then suction pile ones. And we've seen really good results in terms of the analysis we use in this tethering. So increase the fatigue operability by up to 400 times. So they are a very effective tool, but in terms of efficiency and trying to get your cost as low as possible for your P&A, there is time associated with setting those up and getting that used. And also, it then means that you're moving your point loading on that stress further up the stack from the wellhead. The second option is kind of a fixed frame, which is very similar to the tethering. Basically keeps the asset in a rigid state and preventing any kind of loading going back through the wellhead and that surface casing. And then the third one there is kind of a newer technology that we're seeing, and it's a reactive flex joint. So it's basically quite similar in the way of a traditional flex joint, except it's got the ability to actually apply a force back in when it starts to see that flex to try and keep everything in alignment to prevent you putting stress onto the asset subsea and to try and really keep your fatigue down. And another thing that we've kind of seen over the years that's been very useful in tracking how effective these are is doing subsea BOP monitoring, which actually looks at the angle that you're seeing, and that allows you to track fatigue that you're actually seeing on the asset day by day. And you know your operational window that it was before it started, and that can feed back in, and you can see if you've got more or less or how the BOP is actually reacting. So in terms of the operability, we've got a few charts there that show your kind of normal in drilling and operational for the offset of the vessel compared to the wave height that you're seeing. So up at the top there, we've got a lower BOP, a kind of standard generation BOP, if you like, with no mitigation. So you can see their operability is effectively none. You're really kind of looking at absolute miracle windows to be able to operate in there. When you then look at the tethering, it's greatly increased, so it becomes kind of a usable window. And as I said before, we see tethering really increasing the windows that you can have massively. But an alternative that's good to explore, and it can be very usable and very cost effective, is using a lighter BOP stack. So we see there, if you drop the weight down to 8 ton, that does give you a workable window, which, depending on the wells and the circumstances, that could be perfectly usable for the operations that you've got and prevent the need for tethering. This again is just kind of coupled into the same scenarios, but looking at the fatigue life. Again, the tethering there, a huge increase in the workable window of days that you've got. But again, we can see that going from the standard BOP to a potentially lighter weight BOP effectively doubles your window that you've got. And if you're looking at quite a short campaign in terms of P&A and an uncomplex well, that could be a perfectly workable window to get on there and achieve what you need. In terms of the BOP, there's a lot of options currently as technology's advanced, so have BOPs and the options are out there. But one thing that we've been looking at as a company is modifying our current BOP stacks to look at what weight reduction we could have. And in terms of keeping those still aligned with API S53, but looking at what we actually need in terms of class of BOP for the operations that we're going to be going on and doing. So there's a lot of things that you can remove from the BOP that allows us to kind of reduce that by about 55 tons, which also takes about 10 feet off the height, which is also good for your stress analysis and where you're seeing the loading points on the string. So just in terms of some conclusions for that, the P&A operations require a different mentality. Obviously, efficiency is key here, keeping costs low, and in terms of looking at the BOPs, it's about kind of assessing the risk of the wells that we've got, and that front-end engineering and categorizing and looking at the risk of the wells, using that to drive what you actually need for the project, and looking at these BOPs as fit for the project rather than just needs to be a standard class 5, class 6 BOP. Because we've seen that using that low weight, it's highly beneficial. There's cost savings to be made there, time efficiencies to be made, especially when you start looking at batch operations and having to move around tensioners. It adds a lot of time onto your operation. And the aging infrastructure that we're seeing globally, a lot of them fall into this category of just out of spec. So when you start looking at this, because you've got those conservative assumptions, the fatigue is very low and you're seeing really short times. It's pushing you just away from that risk profile that you might want to see. So it's a large problem that it kind of needs quite a lot of focus on to try and make it as efficient as everyone possibly can. And this kind of feeds back into the first point, what are the consequences of failure in P&A operations? And that's about understanding the wells as best you can and the risk profile that they have to allow you to really assess what's required for that project and what the consequences are throughout that P&A operations. And that's it for me, so I don't know if there's any questions.
Thank you very much indeed, Neil. Great presentation. Any questions?
G'day, Neil. So how many of these smaller stacks are you aware of that are operating in around the world?
That's a good question. I'm not aware of any that have been used in operation. I've looked at kind of some of the base cases we've done of styles of BOPs. That's between looking at electric style EH BOPs to reduce weight to the slimline ones that we're looking at. But personally, I'm not too sure on how many are actually being used. But it's something that we're looking to try and push entirely for sure. Yes. So, basically looking at the existing BOPs that we have and how we can basically make reductions on them, and then being able to adapt them between class 3, 4, 5, 6, whatever we think we need for that operation.
Any other questions for Neil?
If you look at the intervention riser, they gave a significantly better outcome, basically infinite. Are you looking at efficient changeover because you have to do intervention as well, do as much on those kind of systems as well, minimizing BOP use, stuff like that? Yeah,
so that's pretty key to it as well as what we see, and that's part of the categorization at the front end. So yes, we have rigs and we have BOPs, but ultimately if we can avoid using those and there's a more efficient way to do it, and that's what we push to do. And that's, looking at lighter intervention stacks or even looking at open water, if that's something that you can do. So, what I was saying about BOP to suit the project, I guess it's more encompassing than that. It's what does the project actually need, and is that any sort of well control package, or is it something that could be lighter again?
If there's no other questions, thank you very much indeed, Neil. Excellent presentation.
No problem. Thank you.